Introduction to layer 2 switching. Actually, we have two types of switches, layer 2 and layer 3. And layer 3 switch is also called as multi-layer switch because it can be used at layer 2 and also at layer 3. Okay. Earlier, when just only they wanted to communicate, what did they do was they used to keep one main cable, coaxial cable. Okay, keep one cable. This is a coaxial cable to which every device is connected. There are no intelligent devices which controls the data. Okay, if everyone wants to communicate with this server, as I told you, CSMA CD, collision detection, from Mary and John, same happens here. If this fellow PC 1, 2, 3, 4, if 4 wants to get data from the server, first he have to check whether this resource is free or not. Then only he can generate the request. He will receive. Once he is done, then he will do. If simultaneously 2 and 3 generated the data, collision. This is what used to happen. Okay, so this is the device where you connect. And next what happened is they thought like this is not the best way. They introduced this hub. What is the purpose? It does the same. In order to this fellow, in order to get the data, first he has to send the pulse. After confirming that this resource is not busy, if it is busy he will cancel, if it is not busy he will send the request. But what is the purpose of adding them here? Actually, here, for suppose if the server is not this much close, it is somewhere around, by the time it sends the request, by the time it reaches here it becomes weak. In order to re-strengthen strengthen that signal, okay, in order to re-strengthen, we use hubs or repeaters. What will they do is, by the time it received the signal, it will again repeat that signal and send it. By this what happened, loss of signals or loss of packets is reduced. Oh, so these are the transceivers or the repeaters, you can say. And repeaters will generally use for every 100 meters. As I told you, the board has decided that the maximum distance should be 100 meters. For every 100 meters, one repeater is used. Okay. And one more problem was, if this server is sending the reply, this hub is not that intelligent. Whatever the data, whatever the packet it got, what it used to do is, whatever the packet it got, it simply used to broadcast it. It used to send this side, this side, this side. It just used to broadcast it. Okay. Hub is always under one collision domain. And one broadcast domain. That is what happened. Whatever the packet it received, it is not that intelligent. So it used to broadcast it. Now unnecessarily, this fellow he generated the request. Now whatever the reply he gets, everyone will receive it, even though they're not required. Whoever generates a request, reply comes and everyone will receive it. So what did they thought is, no, this is not working out. So what did they do is, they came up with the concept of bridge. Bridge is very simple. It is little intelligent that it will learn MAC address. For suppose it is connected This is my port number 1. This is my port number 2. This is my port number 3. Usman, you getting it?
Yeah.
On this, I have a device A. On this, I have a device B. On this, I have a device C. Right? Now, what this bridge started doing is, I sent the packet first. If as soon as you got the packet, it will start making entries in the table. What is my port number and what is the MAC address in the frame? Source MAC address, not the destination, only the source. What is the source MAC? It is A, maintained. Similarly on 2 it maintained B. Similarly on 3 it maintained C. Now it sent a unicast to B. It is intelligent. It has seen for destination. What is the destination of this packet? It is B. It will check on which port should I send it. Port number 2. It will only send out 3. Port number. Okay. I'll tell you a story. This is hub. First, suppose this is hub. I'm here. Or else, uh, good boy. He's good boy. He's using this PC. Good girl, ultimately. Here is a user bad boy. Good boy is sending a message. I love you. Hub. It doesn't know. It is not that intelligent. It send it this side. This side. Bad boy came to know there is some fish happening between good boy and good girl. He wanted to know. Today it's okay. It's just a message. It's okay. But tomorrow this fellow sends some personal message. He will come to know. Even good girl come to know. They doesn't know that there is a hub in between. Right? They doesn't know there is a hub in between. They are able to communicate. But what's happening? Bad boy is also able to see the communication, what everything is happening. Right? Now, bad boy on some fine day, he went to good girl. He blackmailed him. Why all this has happened? Because of hub. Now good boy came to know this. Bad boy is doing some fish between me and my girl. What he did, he acted intelligent, and now what he did, Chrome bridge. He introduced bridge here. Same good boy, same good girl, but again the same bad boy. Now this fellow he started waiting for the messages. Early in the morning he came and he sat and he's waiting for the conversation. These guys they are able to communicate. He waited the whole day, but he is not able to get the messages. Why? Because bridge has become intelligent. It started learning MAC address and it started sending unicast. This is the purpose of bridge. It is intelligent. It can come to know to which device should I send this packet or the frame. That is the basic difference between the hub and bridge. Right? Here also the same. According to the story, here also the same. It sent the packet to the destination. So that is the purpose of the bridge, where it is little intelligent. It will make note of all the MAC addresses and watch it out. Which interface did I get this MAC? And next time, if it gets a destination MAC for that, it will directly send through that. And broadcasting will never be happen until and unless the device generates the broadcast path. Okay. Yeah, you have some cases where though the MAC address exists, the switch does what? A unicast packet as a broadcast. That is all you'll learn in CMP and CCIE. You'll have some various cases. After all, they are devices. We are humans. We can do everything with them. Yeah. So switch. The difference between bridge and switch is very simple. Switch has more ports than bridge. Bridge has some limited ports, like router. It might be having at max around 4 to 5 ports. That's nothing more than. But switch, if you want to connect a network, okay, which is of some 40 to 50 devices, if you want to connect them, instead of bringing around 10 to 15 bridges, it would be better if you get one switch. That is the first purpose. And switches are more intelligent than bridges. They are little faster than bridges because they have some separate switching engines for various purposes than bridges. So switches are preferred nowadays. But the nomenclature for some protocols in the switching, they still remain as bridge protocols today. That is because of their because at that time bridges were used at that level. Okay, so I told you the difference. That is the thing. The switches are little intelligent, more intelligent than bridges. They have separate switching engines and they have more ports than bridges. Yeah.